is in your syllabus, because in gravitation the syllabus has changed. The portion has been changed. What you are going to have is gravitational field, gravitational potential, gravitational field intensity, gravitational potential energy. That will be the first part. Second part will be orbital speed, escape velocity, geostationary satellites. Two parts are there. If I start with gravitational field, you will find it difficult. So what I'll do is I'll start with orbital speed, then we'll go for escape velocity, then we'll start with gravitational field. Okay, is that clear, boys? So far what you have learned is only the introductory part. I'm just repeating repeating what, as per your portion, it should be first what is a gravitational field, what do you mean by gravitational field intensity, what is gravitational potential, what is gravitational potential energy. This is the first part. Second part, orbital speed, escape velocity, geostationary satellites. See, you people would have studied about magnetism. You have studied about magnetism. Grade 10, did you study about your magnetism, boys? 11B. 11th standard. Did you study about
yes,
magnetism?
Yes, ma'am.
You know what is, okay, especially the magnetic field around a bar magnet. So you know what is a magnetic field. You know what is, how you represent a magnetic field, right? Only this much you have learned in grade 9. Why I'm saying is that when you study about magnetic field, electric field, gravitational field, these are the three fields you will be studying in physics, right? Magnetic field, you very well know. What is a magnetic field? A region around a magnet where the magnetic force due to the magnet can be felt. That is what we call it as a magnetic field. How do you represent your magnetic field? You represent magnetic field by magnetic field lines. Now, what is a magnetic field line? I'm just recalling what you people have learned in grade 10. Now, this is what about your magnetic field. Now, in grade 11, you will be studying about gravitational field, but in grade 12, you will be studying about electric field. The concepts are going to be the same, boys. The concept is the same. What is a gravitational field? What is a magnetic field? What is an electric field? So whatever you learn gravitational field, the same analogous of electric field, you will be studying next year in a very elaborate way. The first two chapters of your 12th grade will be electric field. So if you understand gravitational field, you will easily understand your electric field. So there are takeover from grade 11 to grade 12. Concepts will be the same, but fields will be different. So I thought if I start with gravitational field, it will be for you to, it's all hypothetically, right? You have to imagine. So what I thought is, let me finish your orbital speed. Let us finish escape velocity, geostationary satellite, and then come back to gravitational potential. So I'll start with orbital speed. You know what do you mean by orbital speed? So all the satellites which you launch, right? Whenever they launch a satellite, the satellite should revolve around your Earth in certain orbit with a certain velocity. So, right, if you so sometimes have you heard about parking orbits? Have you heard about parking orbits, especially the satellites which are used for telecommunication? You and you people cannot be using your system if you don't have these satellites. Telecommunication, you very well know about it. 11B, you are not answering at all. 11B.
Yes, ma'am, I'm listening, ma'am.
Okay. Geostationary satellites, there are different types of satellites. Geostationary satellites, those are the satellites which you use for your uh, communication, telecommunication. And there are polar satellites which are used for, say, they use for military purpose, they use for just check for mining industries, right? To check, and for even weather forecasting. Those are called polar satellites. These geostationary satellites are different. They are used for telecommunication purposes. It depends upon what height the satellite is all about, whether it is polar or whether it is geostationary satellite. So one will be revolving around, the orbit will be passing through the poles of the Earth. Anyway, polar satellites are not there for you. It's only geostationary satellites. We'll see why it is called a geostationary satellite later on. So whenever a satellite revolves around the Earth in an orbit, it has some velocity. That velocity, what we call it as orbital velocity. Now, how do you determine for particular orbit? There will be already they'll calculate, right? If I want a satellite to revolve around the Earth in certain orbit, then it by mathematical calculation they'll derive what is the speed it should have. What should be the speed, right? If they know the speed, then have you seen your rocket system? Have you seen rocket system? Is it a multi-stage rocket system? Have you heard about multi-stage rocket system,
Yes,
boys?
ma'am.
You
Yes.
have only one stage. You don't have one stage. You have three-stage rocket system. One is to make the satellite. Sorry, one is to make the satellite to take higher up, and then for that one of your rocket system should burn, give that energy so that it goes straight up. Have you seen the launching pad? Launching pad will not be on your ground. Yes, boys. Launching pad will never be, yeah, will never be on the surface of the Earth. It will be at a greater height, right? So that the air resistance will be less. Energy spent by the fuel can be reduced. So one is to take your payload. We call this as a payload straight up. Next stage rocket will burn. It will give a horizontal push. The third stage rocket will put third stage rocket system. That means the fuel system. So there might be multiple stage rocket system, basically three-stage rocket system. One is for vertical projection, the other one for horizontal. The third one is for putting the satellite into an orbit. 1 second, boys. Let me see, check whether there is a small animation. 1 second, I'll put this in your, I'll copy paste this in your chat box. Let us see whether you can operate this. Now, the basic principle of,
Ma'am, are you sharing your screen?
it's not seen? Okay, fine.
No, ma'am.
1 second, I will just. Just check, boys, whether you can access this. Just check 1 second. Can you access this, boys? Can you access this? This sorry, the simulation, can you all access? I have put it in the chat box. Can you
Yes.
see that?
Yeah.
1 second. Okay. I'm not able to. Wait 1 second, desktop. Can you see the simulation? Because I don't know whether you can you see the simulation on screen?
Yes, ma'am. Yes, ma'am.
The simulation on screen. You can see some the Earth, then a cannon. I'm not able to. No, it's not the PowerPoint presentation. I'm not telling you the talking about the PowerPoint presentation. I'm talking about the simulation. Can
Yes,
you
ma'am.
see?
Yes, ma'am. I
Okay,
can
fine.
see the simulation of. Yes, ma'am. It's the
So
cannon
in
on
that
Earth.
case, yeah, this Newton cannon experiment gives a brief idea how a satellite should be fired into an orbit. Right now, let us check for. Okay, you have a cannon where you can fire the shell. So let me put the initial velocity of the shell as 1. Right? 1 kilometer per second. When the cannon is being fired with a speed of 1 kilometer per second, it falls on the surface of the Earth. The curvature keeps second one, where I'm just increasing the speed to 2 kilometers per second. Then can you see the curvature keeps increasing, the range of the projectile keeps increasing? Are you people able to access your system? So 4. So as you keep increasing, now look what is happening. As you keep increasing, the range of the projectile keeps increasing, but still it is capable of reaching the surface of the earth. Right? 7. Now when you go to 7, are you clear now? So when your speed, the speed with which you project an project an projectile with 7.59 kilometers per hour, this should be the minimum one. This should be the minimum one, boys. Then what happens? It will never come back to the surface of the earth, but it keeps still revolving around the earth. 11B, I'm just asking you whether you people can see this on the simulation which I'm operating on screen.
Yes, ma'am. We can see it. Yes, ma'am.
Yes, ma'am, we can see it.
Okay, can you access your simulation? Can you access your simulation? Okay, keep increasing the speed. Let us see what happens. Keep increasing. Let me increase the speed to 7, 9. Okay, let me. Okay, now you can see the trajectory itself is changing. Let me increase to 10. Right? Is it now becoming an elliptical orbit? Right? So now what happens? It's escape velocity. It escapes the Earth's gravitational field. Can't say that it escapes the Earth's gravitational field. You can say that it never returns back to the surface of the Earth. It is not under the influence of Earth's gravitational field. That's it, what we can say. So if you want any object to move out of the surface of the Earth, then the escape velocity is 11.2 kilometers per second. You have to throw an object at a speed of 11.2 kilometers per second so that the object will never turn back to the surface of the Earth. Now for us, it is orbital speed, the minimum speed with which you can project an object so that it moves with a speed of 7.9 kilometers per second. Now here, your cannonball is placed, you're firing it horizontally, boys. You're firing the object horizontally. This is just an experiment, hypothetical experiment by Newton. We call this as Newton's cannonball experiment. But generally, when you're launching your satellites, keep this in mind. You have multi-stage rocket system. Each stage, one stage will put the rocket move in the vertical direction. Then the second rocket stage will give a horizontal projection. The third one will put it in an orbit. So minimum 3-stage rocket system. So let us go for an deriving an expression and go for deriving an expression for the orbital speed. Yes.
Ma'am, all the derivations and formulae we did till now, they're not in our portion, right?
They are not in the portion, but what is being specified is that it should be a recapitulation. So that is why I have recapitulated it. Okay? It is not there in your portion. It's there in your portion only as a reference, not for examination.
Okay, ma'am. Thank you.
Okay. Now, okay, boss. Just do you have an idea, boss? Do you have an idea? Will the orbital speed will be different for different objects? The orbital speed, say I have two different satellites, right? There might be their masses are different. Right? Will your orbital velocity will be the same? Will be same or different for different object? Okay. Let us see whether your orbital speed, yeah, it's going to be the same. It varies with the mass of the satellite. Do you think the orbital velocity is going to change with the mass of the satellite? Does the mass plays an important part?
No, ma'am.
A satellite? No. Let us see that. Boys, please start writing the statement. Orbital velocity The velocity with which a satellite moves in its closed orbit is called the orbital velocity. The velocity with which a satellite moves in its closed orbit is called orbital velocity.
Ma'am, we still have to complete the variation of acceleration due to gravity with depth.
Altitude? With the
No, ma'am.
depth.
Yeah, with depth. We were on that special case.
Okay, just remind me when I come to the last class, I'll just go through it once again because it's not included in your examination portion. It's only recapitulation. Just remind me, boys. Last period I have a class. I'll just put it over there. Okay. Fine. Have you completed this, boys? Can you draw the diagram? Can you draw the diagram? Now look at the diagram. Boys, can you see the Earth of radius r? Let m be the mass of the Earth, and r be its radius. You have a satellite which is revolving around the Earth in an orbit of radius r with a velocity vc. I can put the velocity vc, and at a height h above the surface of the Earth. Right? Capital M is the mass of the Earth. Capital R is the radius of the Earth. Let us consider a satellite of mass small m moving in an orbit around the Earth of radius small r with a velocity vc at a height h above the surface of the Earth. Draw the diagram. One second, boys. Let me see whether the introductory part is there. So you draw the diagram and write the statement. So it's moving with a velocity vc, and the radius of the circular orbit r is equal to r plus h. 1 second, boys. You just keep doing your work. 1 second. Have you copied? Boys, an important 3-mark question, since your most of the portions have been, some portions have been deleted in your gravitation. Please understand, these are very, very important 3-mark questions. A derivation, let it be orbital speed or let it be escape velocity. If it might come as a 5-mark question. 3 marks for derivation, 2 marks might be for numerical. Please do understand the concept. It's not tough. Okay. So when you start with this, 2 things are important, boys. Whenever you start with a derivation, you should know where you are starting with, right? Now look at this. The satellite is moving in a circular orbit. It's undergoing a circular motion. Now, what is the condition for any body to undergo circular motion? What force should be there for the body to undergo circular motion? Centripetal force. Boys, whenever a body undergoes a circular motion, there should be always a force acting towards the center. We call this as the centripetal force. Is that clear, boys? Now, the force is acting towards the center. So, when the satellite is moving around the Earth in an orbit, there should be a centripetal force which is pulling the satellite towards the center. Now, what provides the centripetal force over here? Suppose an electron is revolving around the nucleus. Suppose you have an electron revolving around the nucleus. What provides the centripetal force? What provides the centripetal force? What pulls the electrons towards the orbit? Otherwise, electrons will fly away.
The nuclear charge.
Is the force exerted by your nucleus on the electron. Was understand, the force exerted by the nucleus on the electron provides the centripetal force. What makes the planets to revolve around the Earth? The force exerted by the sun on the planets provides the centripetal force. Otherwise, Earth cannot move around the sun or any other planet for that matter. So whenever an object is revolving in a circular in a circular path, there should always be a force acting towards the center, what we call it as the centripetal force. If electron is revolving around the nucleus, then the centripetal force is provided by the nucleus applying a force on the electron. Now look at this. A satellite is moving around the Earth. So what provides the centripetal force? You have two objects, right boys? Please understand you have two objects. One is Earth of mass m, the other one satellite of mass m. What is the force between these two? What do you call this force? The force exerted by the Earth.
Gravitational force.
Gravitational force. Right? There are two bodies. Please understand there are two bodies in the universe, right? One is the satellite of mass m, the other one is the Earth of mass capital M. And the force between them is your gravitational force. From Newton's law of gravitation, what is the force between them? What is the force between Earth and the satellite?
Like GMM by R square.
Yeah, correct. So, correct. It's a gravitational force, correct, boys? See, boys, there are so many derivations. If you don't understand what we call the skeleton of how you are going to derive, then you will find it very difficult. Please understand the concept. Then easily you can arrive at the expression, boys. What is important? When the satellite is revolving around the Earth, the centripetal force is provided by the gravitational force of attraction between the satellite and the Earth. Then you equate these both equations, you will get an expression for the orbital velocity. Is that clear? 11B, is that clear? Joe Paul, Jonathan? Joe Paul and
Yes.
Jonathan?
Yes.
Okay. Okay, boy. Now you start writing. First, please write centripetal force, at least write centripetal force acting on the satellite is equal to gravitational force between the Earth and the satellite. Gravitational force between the Earth and the satellite. Earth and the satellite. So what is the centripetal force? How will you write centripetal force? What is the expression for the centripetal force? Harish, what is the expression? General equation for centripetal force. Harish, what is the general equation for the centripetal force? Use mv squared by r, correct? Boys, the general equation for centripetal force mv squared by r. Grade 11, even if you wake up, you should know this expression. Because you are learning so much of this concept of circular motion. So the centripetal force, this will be carried over in grade 12 also. Boys, please understand the centripetal force between the satellite and the Earth. What is the general equation? mv squared divided by r. So let me write m. So we have taken the velocity as vc. The radius of the Earth, orbit is r. M is the mass of the satellite. Vc is its velocity, and then r is the radius. Vc squared by r. So what is the gravitational force? Surya, what is the expression for the gravitational force between the Earth and the satellite? Surya?
G is equals to gm by r square.
Gmm divided by r square. Okay, can you get an expression? Can you all get an expression for Vc? Boys, can you get an expression for Vc? Cancel off r on both the sides. So can someone get me an expression? Zuhair, what is Vc? Zuhair?
Yes, ma'am.
What is Vc squared, Zuhair? Okay, 1 second, Zuhair. What is Vc squared? What is Vc squared, Zuhair?
Not sure.
G? What is VC squared?
Capital M.
Capital M divided by?
R.
Divided by R.
Small. Okay. Then what is VC now? GM
Root of
divided.
GM by R.
Okay, fine. Rishit. Rishit. Okay, can we substitute for R? What is R? The radius of the orbit. H is the height of the satellite. R is the radius of the Earth. R plus H, correct? Is that correct, boys?
Yes, ma'am.
Okay. You just mark this as equation 1. Mark this as equation 1. Okay. Now look at this. I want VC, boys, please understand. I want an expression for VC, not in terms of G and M. Are you clear? I want an expression of VC, not in terms of gravitation constant and the mass of the Earth. I don't want in this term. I have to replace GM. Now, how will I replace GM? Just write this expression, boys. Have you all copied? Have you all copied?
Yes, ma'am.
Okay. Now, what we'll do is, what is the general expression for acceleration due to gravity? Suppose the body is lying on the surface of the Earth, right? A freely falling body. What is a general expression for acceleration due to gravity at the surface of the Earth?
GM by R.
GM by R square.
Okay. GM divided by R square. Right. Now, this is when the body was acceleration due to gravity, when the body is nearly on the surface of the Earth, when the body is on the surface of the Earth, correct? When the body is on the surface of the Earth. Fine. Now look at the other one. Now the satellite is at a height h above the ground. Please understand, your satellite is at a height h above the ground, right? So I can always, when you measure the distance between the satellite and the Earth, boys, whenever you measure distances between two bodies, always from the center of one body to the center of the other body. Are you clear? Whenever you measure the distance between two bodies, it's always from the center of one body to the center of the other body. Must please do right. Acceleration due to gravity when the body is on the surface of the Earth. G is equal to GM divided by R square. So I'll continue in the next class.
Thank you, ma'am.
Thank you, boys. Boys, an easy derivation. Please concentrate, boys. It's very important from your, you can expect this in your examination either as a 5 marks or the 3 marks. Thank you, boys.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you. You have a break now or you have a class?